This question is taken from the ENGAA 2020 section 1 paper, and it is question 29. So we read, a 3 kilogram box is pulled 5 meters up a smooth slope by a constant applied force of 30 newtons. The initial speed is 3 meters per second and final speed 7 meters per second. So this could be suvat or energy. So we have a diagram over here. What is the component of weight acting down the slope? Well, immediately I think we're given the velocities, so this could relate to kinetic energy, and then we have some forces and a distance. So this could be the change in kinetic energy going up from one point to another is equal to the resultant force times the distance moved. So this will be responsible for why the speeds are different. So if we incorporate this information, we have a half times 3 for the mass times the difference in speed squared is resultant force times 5. So this is a half times 3 times, this should give us 40, so the total should be 60, and therefore the resultant force is 12 newtons. So this is essentially the work done was 60 joules, so the resultant force overall was 12 newtons, and we know the part pulling us up was 30 newtons, so the part that must have been acting against this to give us our resultant force was 18 newtons. So this force parallel, to show that it's going along the slope but down the opposite way, is 18 newtons. Another way that we could have done this, but would have been quite a bit longer, is to work out how much work done we would have got just by the 30 Newton force, and then however much work must have been lost by doing work against the 18 newtons. And this might have been longer, so it's best to work with the resultant force and then deduce that we had 18 newtons going down.